Hello, welcome back to this new session. I'm here with Patrick Baumgartner, and we are going to talk about Spring Boot applications. So, Java World, how to build application for the cloud. Patrick is an experienced architect and developer that he worked on a number of framework belonging to the Spring and the Java ecosystem, and he is actively involved as a software crafter and agile community. So thank you for your time. Thank you for joining us, Patrick. And I'm going to give you the stage.
Thank you very much, Luca. So I'm looking forward to talk to you about small and lightweight applications for the cloud. And probably all of us have like similar issues when we deploy Java applications or Spring applications to a cloud environment. So I would love to, now let me see. I would love to actually like give you some insights, what you can actually improve and like what you can change in your application. So usually I say, I'm going to show you things Josh Long, the Spring Developer Advocate, is not going to show you. And I show you also like data or numbers, like how things are performing basically. Because I did some benchmarks, I measure the things myself, so I can actually like see what's going on behind the scenes. Great. So Luca already introduced me a bit, but also like to let you know, as he said, I do architecture, I do coaching on the job, I do development, I do reviews, and I even do trainings with focus on Spring. And besides my day job, basically, I also teach at the University of Applied Sciences in Zurich as well. So teaching is also like a big thing. And as also Luca mentioned before, I'm also part of the Java user group and the software development community in Zurich in general. So I'm also heavily involved there in events and on conferences and other things. So what's the problem? What is this talk about? So because I'm a Spring guy since many years, I want actually like that my application we have built in the past also perform very well in production. So basically in the cloud these days. So let's dive into the topic. So you may think of, or you may know that people approach you and ask you like, how much CPU, how much RAM is your application needing in the cloud environment? Well, often we don't know, so we would have to measure and see like how the application behaves, right? And then on the other side, also like when you deploy things to cloud, it maybe is important how much like container image size you have as well, because like that depends on how fast a container image is pulled from the repository. And if you have to push your image like even to like a cloud like which is far away, it may also take some time as well. And then on the other hand, the question is also like, yeah, which technology should we use for our cloud applications? You would say, obviously, if you're like a Java person or a Java developer, you would probably say that we are not going to change like the ecosystem. We are not going to change the programming language just because it's more performant, because we know that like things change a little bit slower in the Java world, but they're super mature. So it just usually takes some time until the Java ecosystem actually like picks up. So like for us, which is now very important, it's usually like CPU and RAM, as I mentioned before. And you can imagine that like several cloud vendors are not even like linear scale like CPU and RAM. Sometimes you have to like, just because you need more RAM, also pay for more CPU, right? And another thing would be like the image size, as I mentioned before, also like costs more because you need to provide some traffic. You have some network bandwidth needed to like send your images around. Obviously, from an application perspective, you would say scalability is also very important. So that means like fast startup and maybe graceful shutdown if you have something like an autoscaler in place. Another topic would be like data throughput, like how much can my application like resist, how many users can it deal with? And then on the other hand is like the question, how long does it take until the response is sent back? right? So these are all things we should have in mind if we deal with our application. So we are going to talk about the Spring Pet Clinic. And in my agenda, I will just show you like what the Spring Pet Clinic is. We do a baseline, and then we jump into Java optimization, Spring Boot optimization, application optimizations, other runtimes, some conclusions, and then in the end, some summarized example, right? So that's actually like what I would go through with you in the next 40-ish minutes. The Spring Pet Clinic is actually a very simple application, and it's a demo or showcase application for a lot of features. And it has been used also for other Java frameworks where they are like trying to re-implement the Pet Clinic, because it's just a good showcase with like many different interaction possibilities for a user. So as you can see on the slide, and basically like some data is populated. So you have some pagination, you have some forms, you can send the data in, and so on and so forth, right? Then actually also like the Pet Clinic is also famous because there is a Pet Clinic community, and the Pet Clinic community might help you when you try to implement something like Angular or React with Spring Boot in the backend, right? There are other examples out there, and the Pet Clinic is not an official Spring ecosystem project, or the Pet Clinic community actually is not official Spring. It's community maintained. So that's why we have that many and even more examples you can try out if you want to. For the talk, it's very important I go with the official Pet Clinic. So the official Pet Clinic is an official Spring framework or a Spring framework ecosystem project, and it's based on Spring Boot these days. It uses Caffeine as caching, server-side rendering of HTML. We have Spring Data JPA for the data access. We might choose between H2, Postgres, or MySQL. For my example, I'm using just like H2. Let's keep that in mind. And for the controllers, it uses Spring MVC. So some good old technology, like basically everywhere. So be aware of this. We are just dealing with the official Pet Clinic then also for the rest of the presentation. Now, if you want to optimize, obviously, there is a few things to be aware of. Now, before doing experiments, I want to narrow down the technology stack we are using. We are going to create Docker containers with build packs. So something which is native to the Spring Boot ecosystem anyway, even though I'm always realizing that not many are using build packs to create their containers, but I will use that in my example. I use for my baseline the Java JDK 17, so the latest version of it, and also the latest version of Spring Boot, being aware of that in 2 days, Spring Boot 3.3 will be released, right? And then on the other hand, also like for testing, we use test containers because that's part of the stack. And then actually also use some migration script to do the DB migration to populate the data into the application, which is basically part of the startup sequence of the application. On the other side, when we are going to examine the data, we will have a look at build time, startup time, resource usage, basically RAM. I'm not really counting their CPU because that's a little bit more complicated to basically like get one number out of it. And then actually also like we look at the container image size and also the throughput of the application. So that means basically like how many requests go through a second, for example. So just to mention here, build packs again. Build packs is a very nice project which helps me to build Docker containers. Usually I mention build packs with the Paketo ecosystem. Paketo is just the implementation. Build packs is the standard. And Paketo actually like helps me to package any kind of application, as you see the logos there, into a Docker container. It will create a very nice Docker container and reduce the cognitive load of a software developer. So a software developer does not need to know how the container is built because they use some standard approaches to build these container images. If you haven't tried it before, I will really like encourage you to do so, because I think actually like it's the best way to do the perfect container, because build packs help you, for example, to run your processes without, for example, a privileged user and other things. So usually it's like very much optimized. If you look at the application which starts up, so that the Spring Pet Clinic application, you will see the logs. And in the logs, the first 20-ish lines, or maybe 10-ish lines on top, this is something which comes actually like from the build packs. There is a thing actually used, and you can barely see it. It's called memory calculator. And the memory calculator actually like tunes already your JVM as you need it. As much resources are allocated for your Docker container, like CPU and memory, it will use that, for example, to deal with the parameters for the heap size and stuff like that. What also is visible there is, for example, that the JVM gets the current CA certificates loaded, and also what you would realize as well, and that's just like below the logo of the pet clinic, you would, for example, also see that there is a user which is not a root user running the process. The user, if you can see it, is called CNB. And then actually also besides that, things like Spring Cloud bindings are enabled. So that means, for example, that liveness and readiness probes for Kubernetes are turned on automatically for you if you use Actuator, for example. So you see actually like very good defaults are there, and even defaults which you would have to like set up manually can be actually like calculated dynamically. So in other words, build packs are 1,000 times better than your regular Docker file. It's more secured, and like one other big advantage is actually like that build packs are maintained by the build packs community. So if the base image, and that's usually an Ubuntu Jammy, has a vulnerability, it's fixed within 2 to 3 days, because as soon as Canonical, the company behind Ubuntu, is like fixing the library or like provides a patch or something, it gets upstream directly into build packs. So I don't have to care about that. I always can like work with the latest and greatest base image from the build pack community. Right. So before we actually start and have a look at like how we can optimize our application, I want to share with you a tool I came across when I started preparing for this presentation, and it's a tool by Mathieu. Mathieu actually has added or has created a tool which is called Spring Boot Startup Report, which gives you the possibility to read the data which is anyway recorded when a Spring Boot application is starting. And he visualizes it in a nice dashboard. So the dashboard, which is like available under /startup report, would actually like tell you how long it would take to create a single bean, and then even like the whole tree of that particular bean. So you could actually like see like what takes long and what doesn't take so long. And as you can see also at the magnifier, there's a plus and a minus, so you can really like drill down and see like which Spring Beans take very long to be created. That's actually quite interesting. If you have the time once, have a look at it, because I find it actually surprising, because like I have realized that certain things take longer than I have expected. At the bottom of that page, you will find also the very famous flame chart you probably know from other tools as well. And there you could actually like see from bottom up basically the same structure as you have seen above with the magnifier, but here you have the flame charts, and you will see like that certain sections take that amount of time. And you could say like, for example, and that was kind of surprising to me, that initializing Hibernate and Spring Data together takes about 1/4 to 1/5 of the time of the boot time of your Spring Boot application. It's quite a lot, right? So I don't want to say like let's get rid of like Spring Data and Hibernate, but just like let's be aware of that magic which Hibernate makes, beside the magic Spring does, of course, and takes quite a lot of time. So let's start with the benchmarks. And there I want to show you that, for example, when we build the application, how long it takes to build the application, how long or how big actually like the image size of the produced artifact will be. We'll have a look at the startup time, at the memory usage, and then actually we also look at the throughput and the latency with using a tool called WRK2. So the second version kind of like can deal with latency too. And as you see there, usually when I do benchmarks, I think it's fair to have a warm-up phase so that the JIT can actually like jump in, optimize the code, and then I do a minute of measurement. You also see that my environment has 4 virtual CPUs and like 1 GB of RAM, and that might be a little bit too generous comparing to the regular applications we usually deploy, right? You might be aware of that, like people like to have like a half virtual CPU or a quarter virtual CPU, and some are even talking about 0.1 virtual CPUs in production. But the thing is actually like the 4 CPUs for Java applications is basically like the sweet spots to have the application started up the fastest. I will tell you also a little bit more about that at the end. So I just found out actually like that's really like the sweet spot, and it cannot get really, really better by just like doubling the amount of CPU you provide to the application. Right. So that's like what I measure. And just like to start with, I would love to actually create a baseline. And my baseline is always marked in the table with the results at the bottom with this little watch. So you see actually like the build time of your Spring Pet Clinic with Java 17, and with the current version of Java, you see 17.011, and the Java memory calculator in place takes about, the building of this takes about 67 seconds. The image size of the container will be around 358 megabytes. The startup time of the application is about 4.5 seconds. The RAM usage before we actually like do the load testing, it's 300 megabytes. If we put almost 2000 requests a second on the application, which is actually like possible in this kind of setting with my machine, leads to like 400 and almost 70 megabytes RAM usage just right after the load testing. And then you see the percentiles at the end of the table, which actually like explains that like 50% or of the requests are within 5 milliseconds. You have like 99% are within like 31 milliseconds. And if you go even like 2 decimals after the dot, then you're like within like 160 milliseconds, right? So that's actually quite good. It's really, really nice, these numbers, I would say. So we'll compare this to other things, to other optimizations. I think I need to tell you as well, when I run actually like my benchmarks, I usually run like 10 benchmarks at a time. And then I take off the peaks. So that means like the very good results and the very bad results. And I do an average in the end. So I know basically like that all of my applications runs, as many as if I'm going to do that, they will all end up in these numbers, basically, like kind of averaging. So like the statistical result would be like really confident that most of the runs would be like this, right? So be aware of this. Also, the other thing is actually like I usually like benchmark the application 10 times, average the things. My machine where I do the benchmarking also has like water cooling. So I have consistent water or CPU temperature through the runs. And currently, like with all the optimizations I do and try out and get the numbers off, actually like my application or my whole test suite runs like for more than a half a day, right? So it's quite a lot of effort to take all these numbers and then actually like bring them into the right format, as you can see here. Okay, so be aware of just that's the regular thing. Then on the other hand, let's say we are going to change it. We are going to use like JDK 21. And the JDK 21 can be easily changed just by changing a Maven property. And that would be like what you see actually on the slide as well, where I say like -t Java version equals 21. So I change it, and then I just build the container again. So that means like the container contains now a Java 21, which actually like means that the container image is slightly bigger. Build time is around the same. Startup time, you could argue it's actually like a little bit worse. That could be also like a mistake in my averaging algorithm. But what we see as well is actually like the initial RAM is better, throughput is about the same, and then also like RAM usage afterwards is slightly higher. But if you compare now the percentiles, you would actually see that it gets better towards the end. So it seems like Java 21, from a throughput or latency perspective, is actually like better than the Java 17. Be aware also, and that's really like where I struggle sometimes if I see this, every number in the Java version, like the 2103, if they upgrade to the 2104, the numbers usually like make a huge difference. And going back now to Java 17, where we are already on 17.011, means like they had quite a lot of time to do some performance improvement. And that's actually like what I see quite often. If I jump back to 21, jumping forward to 22, where we have only 22.01 released at the moment, you would actually see that the 22.01, well, is actually like already a bit better, as we can see also from the numbers. So in the percentiles on the lower end, actually like it's about the same, but it's also performing better on the higher end. So I'm really curious like what will happen actually like with the next version of Java, which has also then a longer maintenance phase, or let's say like the next version of Java 21, where Java 21 has a long maintenance phase, and then also the next LTS version again. Usually you see that the LTS versions like get way better over time. And therefore, I have to tell you, it really makes a difference if you upgrade to the latest version of Java. It's not just about latest and greatest. Really, I personally have the feeling that if the new features in Java have to be published, or a new release has to be like made public, they use the time afterwards to do some cleanup, to do some optimizations, and the next releases actually like are way better than actually like the first version of a JDK. Okay, so let's have a look at some parameters we can change. And obviously there is a parameter called like noVerify, which could actually also like improve the startup time. So noVerify is an idea where you say all classes which are loaded are not verified. So that means like starting up the application will be faster. And that's actually like what you see in the slide at the bottom, right? So roughly 4 seconds startup time compared to 4.5 seconds. And you also see actually like we have a better performance. And keep in mind, these benchmarks, they are just made with Java 17. So we always compare about Java 17. We always do some optimization on the 17, or if needed on the newer version, right? I will let you know, but basically like that's why image size and build time is about the same, because I just started with the Java tool options parameter, which will make this noVerify part of the startup of your Spring Boot application. Okay, so what about another one, which is actually like meant to start up fast, right? Tiered stop at level 1 is actually like a parameter which you could use to use the C1 instead of the C2 JIT compiler. And that means like if you specify this, it's really fast at startup, because like the C1 compiler does no overhead in the optimization, so there is no monitoring and other stuff actually there. While as you use actually like the C2, there will be quite a lot of overhead for the monitoring and the profiling and stuff like that for the optimizations. So you could actually say like tiered at stop level 1 means like C1, but if you go for level 2 and level 3 and level 4, you will be in the range of the C2 optimizations. And this parameter usually is used, for example, when you see internally in IntelliJ, when you just like start up your Spring Boot app from the IDE, that parameter is appended so that your Spring Boot app starts faster. But obviously, as we can see, actually, like with the throughput, but also with the percentiles, we see the numbers are just like way too big, right? It's really like on the right side, 18 seconds for the basically like the last request coming back. So we basically sacrifice the performance in the application for a faster startup with this parameter. But obviously, like for functions or like for rarely used applications, it just might be good enough. Okay, another thing actually like could be changing the garbage collector. And changing garbage collector is just like another topic, basically. And I just thought maybe we can do that easily. And I just added in the Java tool options the parameter for the set garbage collector, which is meant as a scalable low latency garbage collector, which stops your application maximum 10 milliseconds from working. And this one actually like is not very well suited for the kind of applications we do. I mean, you could see that we are like with the throughput of the application, we are in the same numbers. But this garbage collector actually like uses way more memory. And that's really the thing. Like here you see like initial RAM is like 1 gigabyte. And then actually like after load test, we have like 1.5 gigabyte memory used, just like for the heap, basically. Okay, so you see actually like with the regular garbage collector we have in there and with the parameters we add with the memory calculator, we are very well suited actually. If you're curious about other parameters, I can highly suggest the VM Options Explorer from chriswhocodes.com. So there you can actually see like which different vendors of the JDK will have which features available. And some of the vendors basically also backport options which are introduced in Java 17 or Java 21, even still to Java 8, right? So if you want to see if your option is available, have a look at the VM Options Explorer, because I think it's a nice tool to see actually like what possibilities you have with your current JDK or JVM you're running. Okay, so now let's dive into the topic where we now discuss like Spring Boot optimizations. And one thing would be like, let's say, let's do all the Spring Beans in a lazy way. All the Spring Beans in a lazy way means actually like they're initialized with the first request, more or less. Or let's say it another way, they are initialized when they're used, right? And you see now in the example above that I specify basically Spring main lazy initialization to true. And I also make sure that Spring Data JPA repositories are also lazy initialized. So what does this bring? The thing is actually like lazy initialization makes the startup faster, right? We see that with the startup time, we see that with the initial RAM consumption. And then afterwards, when we do the benchmarking, we are roughly in the same area with the numbers. And that's actually like what I would expect. So if my benchmark suite actually like does some warm up, all the Spring Beans are anyway initialized. And when I do the minute measuring afterwards, it should behave exactly the same like the baseline, right? So, and that's what we more or less see. We see some numbers which are very close to the expected ones. And obviously, there might be some differences, slightly differences, also like on the next slides I would show you. The thing is just like, I'm not going to cheat the numbers. I don't like them make look beautiful. I just run 10 times and present you the numbers as you can see that. And I will also provide you some additional information on what I would expect, how things would get better, right? So sometimes you could even say like, because we measure things, they're like in a similar range. I think it's just okay-ish what we have here. But obviously, startup is faster. Be aware of having Spring Beans lazy, that might be dangerous. I mean, lazy beans are nice, obviously, as you have seen for startup, but be aware of that when the Spring Beans are created, they might be created with a different thread other than the main thread of Spring Boot. So therefore, your application, if there is a misconfiguration, won't stop immediately at startup. It will just like produces exceptions when you run the application, right? Okay, so Spring Boot has another thing actually like I came across. This is actually like this fixing Spring Boot config locations. Config locations in Spring Boot, they can be for the property files, but also for the YAML files. They can be in different places. And therefore, actually, it really depends like where you place your configuration file. Or even better, you could tell actually Spring Boot that it shouldn't like load the or try to load the files from 4 different places. It should actually like just pick it up from a location you have specified. So that means like 3 files, 4 file system checks versus 1. And that would mean actually like my startup of the application could be slightly faster. And we also see here, well, the numbers doesn't show like a huge benefit. I would also expect that the benefit is really, really small in this case, right? Okay, but now let's go to the next one, which is actually like real brave, because I actually say if you don't need Spring Boot actuator, don't use it. It's really about if you can afford not to use them, don't use them. Because I want to show you like the big difference. Like if you see the Spring Path Clinic with actuators has currently 447 Spring Beans created with the actuator. If you remove the actuator starter, it's just 275. So that's a huge amount of Spring Beans which are missing in the second case. And you can imagine actually like if you don't have to create 170 Spring Beans, your startup should be like way, way faster. On the other hand, you would also expect that like all the observability features and metrics and tracing and other stuff, you know, the logging things, if they're not there, the application should also behave a little bit faster. So you can see now this also in the results, right? But obviously, that's not a serious suggestion. It's just a thing like if you can afford to, don't use it. If not, well, let's deal with it, right? You probably have seen that like your IDE, like your Visual Studio Code or your IntelliJ is actually using JMX to get the data of your Spring Boot application, right? But as you also may know, that Spring Boot actually uses production-ready features. It really means like JMX is actually not enabled in a container built with build packs, but also like if you run application in production. So I just wanted to tell you actually like, I love Spring Boot and build packs because they just do the right thing. And in case you need to enable JMX because you deploy not in a Kubernetes cluster and you maybe want to expose it in a different way, the ambience, you might still like enable them as you are known to do that like from the past. Great. Okay, let's have a look at some application optimizations. Obviously, now we could talk about things like caching your application properly, maybe optimize the queries of your Spring data, and many other things which are really like special to your application. And I tried to find like a way how you can optimize your application or your Spring Boot application in a way so that everyone could actually like do that, you know. So the idea is actually like, let's get rid of some dependencies. And I came across a very neat project, which is actually called the DevClean Maven plugin. And the DevClean Maven plugin is actually like from I think from a Swedish university, where they created a tool which is going to like check like the bytecode, which reads actually like the strings for reflection stuff and other things. And it can really like find out what dependencies you are not using in your application. What it does, it creates a report. And the report was so long, I had to add in multiple places like 3 dots, as you can see on the slide, just to shorten the sections. It reports actually like the dependencies where it knows, for example, it's a transitive dependency, it's maybe an unused dependency, it's a indirect transitive dependency, and so on and so forth. And obviously, it doesn't know anything about Spring Boot. So there are like some specialities in Spring Boot which this tool actually won't find. But what I find personally interesting is actually like that it would find things like you're not using Jackson at all. Do you really want to use Jackson in your application, for example? The thing is actually just like because you're using the Spring Boot starters, these starters are quite opinionated. And that means actually like the starters are built in a way that the Spring team says probably you're going to use a single page application. You're doing this and that and so on, and that's why the dependencies are there. So I usually say starters are good to start with, but they are not here to end or finish the development of the application. So that means like the dependency cleanup is really necessary. And in my case of the Spring Pet Clinic was really the thing that I could actually like remove Jackson. I could remove even like the WebSocket dependencies of Tomcat, for example, because the application just doesn't use WebSocket at all, right? And then actually like you see also some challenges listed for the dependency cleanup. It's basically like all the component and entity scanning Spring Boot does or the corresponding frameworks do. Then actually like you see also that it cannot deal with text files where, for example, auto configurations are listed, and it cannot deal with XML files like the Spring XML configurations or even the web XML files. So you have to be aware of that. There might be some false positives in the report, but as you can see, like in my example, I could strip off like 5 megabytes in container image size just because I removed some dependencies which are not needed, right? Okay, so that's basically the thing. There is another topic which is actually like quite interesting. It's the thing which is called ahead of time processing. And I'm not talking about Graal native images already. I'm talking about that like the Spring configuration can be better automated. So in the previous times, actually, like there was a tool used or available which was called actually Spring Context Indexer, and now this is the replacement for it. So it means I get build time for component scanning, entity scanning, and other things. Actually, like it will be really like optimized, right? And it will actually be faster because this optimization is in place. And yeah, you see now the numbers. Basically, like the generation takes quite a bit longer. The image size is bigger. And you could also say like we are within the same range of the startup time. So I would expect that the numbers are better, but it looks like my machine had also other things to do at that time when measuring, I guess. I'm not sure. But we would say like we're quite in the same range, but we don't need to do component scanning and entity scanning, which is a huge advantage. There is another thing actually, like probably you don't know. It's called JLink, where you create a custom runtime for your application, which is actually like quite nice. You would see here some examples how to do it like on the command line, because JLink is a Java, the JDK tool. But there is also a possibility to use it inside the Spring Boot Maven plugin for the build packs. So you can basically tell the build pack actually like to create a customized JDK. And as you can see on the image size, it's getting way, way smaller, which is actually a good thing, right? And if you do it the right way, like I would do, and you are going to add the modules used manually, you can even strip it down more, which is actually like a huge advantage, right? As you can see as well. And we are also like roughly in the same area with the performance of the application. But as I said, image size gets smaller, right? So you see build packs are awesome. And I hope to see some other things in the future as well in the build packs, because I think of topics like crack or app CDS and other things which could be added actually like by the build packs team. You can actually also go and change the JVM, the underlying JVM. I till now use Liberica, which is actually like the VM supported by the Spring Boot team, and also the VM usually like shipped with IntelliJ. But now you could actually say, oh, I'm going to use, for example, OpenJ9. And that's just like the one-liner where I say I use OpenJ9 instead of like the hotspot VM. And you can actually like do that even like with parameters as we did before. And also you see some numbers where you can see, for example, like the quick start parameter I use for the SQ line there, which actually turns out very horrible, but it is actually like the thing, it's like the JIT compiler C1 we have seen on the hotspot. Then actually like if you look at the virtualized parameter as mentioned on the slide as well, it's getting a bit better, but like the default is like the, yeah, it's actually like better than that. Great. So another thing would be actually like using GraalVM native images. No, not GraalVM native images yet, but just a regular GraalVM. And that's used as a JVM, for example, where the GraalVM is usually slightly bigger because of all the features it has. When running it as a JVM, it has a better JIT compiler. So the GraalVM team is currently looking with the Java JDK team how to integrate their JIT into the JDK, right? So that would be great because we also inherited already from the GraalVM team, for example, the compiler, which is actually the Graal compiler, which you use when you compile your application. So you would see here also like some better numbers just because of the JIT. That's like the GraalVM in the community edition. What is even better actually, like with performance and also with the JIT, is actually like the GraalVM, the Oracle version of it, which is actually called GraalVM Free. So you can actually use it even in production, but it's basically the Oracle distribution. Whereas the other example, or like the thing, yeah, whereas the other example is just like the community edition. Another idea would be actually like to add new builders. And there are builders, which means like you can actually like take off the parameters or the part for the Ubuntu stuff and so on, right? And now we actually do it with this builder for using an Alpine image. I have also done that with the builder actually like for Ubuntu, which is a little bit smaller than the regular one, as you can see also on the numbers as well. So using different builders, exchanging like the base image is actually like quite a good thing. And then of course, what should not be missed here is actually also Graal native images, because everyone talks about that and how much faster it is. What I can tell you is go for the Oracle GraalVM native image version, because it's so much better than actually like the other one, the community edition. You see that in the numbers. And usually like it's not really that fast. If you have really a lot load on your application than the JVM, but like for most of the use cases, it's very nice. And then there are other things like, for example, Crack, where you can snapshot your application, or actually like, let's jump a little bit further and speed that up. And what is actually like missing, it's part of the virtual threads, right? So virtual threads actually like should also like be faster than spawning regular threads. And that's actually like what you see here. For me, actually like using Java 21 and virtual threads with a Spring Boot app is a no-brainer because it's automatically faster. Okay, so let's go to the summary, and I will jump over my conclusion and show you like the best things at the end. So like the optimizations, I just went and actually like optimized the things quite a bit. And there you can actually see like using Java 70 and the builder from Belsoft, you really like improve the image size quite a bit. You get half like the startup time. You basically like have better memory usage and also throughput. And if you think of that one as well, having Java 21 and the base builder with Tiny, it's also way smaller the startup time is even faster with all the optimizations, and your applications have usually also like a better throughput. So I think that's from my side. Did I miss something? Let me know or keep silent. But usually I would love to learn from you as well.
Okay. Thank you very much for the presentation. It's been really super interesting because I think that in the Java world, and when people look to Java, they also miss the point about performances. So you definitely cleared out that application can be optimized, that even the VM can be fine-tuned. So that could be super great. Just a question about using on many different cores, on many different clusters, different configuration. Do you think that can be it can be scripted, it can be make automatic, just delivering this kind of optimization? Is that possible? Do you think?
So actually, like the build packs do quite a lot of things automatically, right? And what I showed in my presentations, these are basically like about 10-ish takeaways every developer can apply tomorrow at work. Because I think like what you have seen was not really like Java parameters to optimize your JVM for different cases. We just went with the defaults because they're in most of the cases are very good already, because it's optimized for default cases, and web applications we write like string in, string out, basically, like that's a common theme. So yes. And then on the other hand, also like doing this kind of like, for example, JLink and other stuff, I think it belongs into the pipeline, right? And also like building the whole images as part of the pipeline. So yes, you should actually automate that. And usually in my projects, I even use like kind of a parent POM where I inherit this kind of configuration. So like we do in all the applications I maintain the same strategy basically. And I can even add every time a bit more, and I learn and I optimize and so on and so forth.
Okay, that's perfect. Great point. Thank you for pointing it out. Thank you for your presentation. Thank you for you attending to this great session, and have a great conference. Bye.
Bye.